So hello everyone. I hope everyone is fine. Welcome back to the channel. So we were in our stack and queue journey. Before this, we have revised our linked list concept in our weekends. So today I have solved two questions, and now we are going ahead in our stack. So we are going with the monotonic stacks. So what are monotonic stacks? So monotonic stacks are basically they are storing the elements, but in a way of order, like either maybe increasing, either or they may be stored in our decreasing order or any other pattern. So if we store in such any pattern, so they are known as monotonic stack. So I have solved two questions of monotonic stack. So let's discuss. So our first question is next greater element. First of all, we have to understand what our problem statement says. So we have given an array, and we will be traversing in our from left to our right direction only, and whichever be the element that is next greater element from our current element, means if we are standing on a point and C point is the next greater element, so we have to just return that next greater element, and our loop will break it at it on that point. So this is the problem statement. So for the brute force, we will able to do is by traversing. So our first loop will be traversing for our I element, and we will taking another loop j that will be from I plus 1 to n minus 1. So we will traverse and check the next greater element, whichever be the next greater element. Whenever we found that, we will simply return that and break the loop, the second loop. So for this brute force, our complexity, for the space complexity, our complexity reaches to big O of n, as we will be taking extra space to store the NGE, next greater element array list. We will be taking a vector where we will be storing those all elements. So, and for the time complexity, its time complexity reaches to big O of n square for the first case. So we all know that it's not the better solution. So what will be the better solution? So before understanding that, let's take an example. Suppose a man is standing and looking the another person's. So depending on their height, he will able to see the person. If let's take a person with 3 feet tall, and he want to see the next element, means next person. So if the person is taller than him, only he can see in that case. So or if the person behind this taller element or behind this taller person is small, so he will not be able to see that person. So here we are just analyzing it, that the man who is standing on a point X is only able to see the man who is taller than him in a row. If the person which are standing and they are smaller than our X person which is standing on the first bench, so he will be not able to see those person. So they are either missing or he doesn't know that they exist. So that's a example, or same we can take example for the pool as well. So this is the example, and we will be utilizing this concept in our stack. So let's start. So for this approach, we will be traversing from our back side to our front side, and the element who is the element which is the largest element, we will be putting that in our stack, and whichever will be the smaller, if it is already in stack and our new element is greater than that element, we will simply pop out those element and put another element in that stack. So let's take a small example. Suppose we have a list of elements 5 3 1 2 4 6. So for the first value, we will be traversing from n minus 1 to 0, and here a quick connect that if the elements are same or equal like 3 or 3, so we will not counting that in our NGE list, because NGE is just next greater element, it will not be the equal element. So with this concept, we move forward. So first element is 6 while traversing back. If it is 6 and there is not any further element which is greater, so we will be simply storing -1 in our vector for the 6 value, and along with that we are pushing the 6 in our stack because it's the largest NGE. So we have put in that in our stack. Now goes on, we get the 4. Now for 4, 6 will be the NGE. So in vector we will be storing 6, and in our stack we are also storing 6. We will be storing 4 because it's our current element. We will be just pushing it in our stack. Now for 2. Now for 2, 4 will be the NGE. So in the vector we will be storing 4, and in our stack we will be pushing 2. Now comes 1. If it's the 1, so we will be pushing 1 and 2 in our and 2 will be stored in our NGE while 1 will be pushed in our stack. Now it's come 3. So for 3, 1 is not the NGE, 2 is not the NGE, 4 will be the NGE. So for this case, firstly we will popping out 1 and 2 because they are smaller than 3. So they are not the NGE and we have not found NGE yet. So after popping 1 and then 2, we will be comparing 4 as 4 is greater than 3. So means we have find out our NGE, and we will be storing 4 in our vector. Uh, we will be storing NGE in our 4 vector, and 3 will be pushed in our stack as now it's the greatest element and it's the current element. So we will be pushing that element. So in this consecutive way, we will be reaching from our end till our start of the array. And in our vector, we are parallelly storing the next NGE of that current element, whichever will be the next current element of our current value. So that's how we will able to solve this problem. That's because due to example I think it's pretty clear that if the elements are smaller and with of our current element, so we have to simply pop them out from the stack as they will not be the NG, and whichever will be the largest will be stored in our vector, and our current value will be stored in our stack. That's quite easy. So for the complexity, its time complexity will be big O of 2n, as for the brute force or for the pseudo course. Firstly we should discuss the pseudo course. So our pseudo code will be, firstly we have taken an NGE and an NGE array or our vector that will be storing the NGE values, and a stack. Loop will be run from n minus 1 to 0, and we will be checking the condition if stack is empty or stack's top element should be less than or equal to array of I. If any of the case arises, we will simply pop them out because those elements will not be our NGE. And again, now we will check if stack is empty and there is not any value, the stack is empty. Our first element encounters where NGE is equals to -1, because for 6 there was not any NGE, so we will be returning -1. Else in case our current value of NGE will be our stack dot top element, and we will simply push back in our stack and storing the NGE for our vector. So that's how we will be able to solve this problem. And our time complexity, big O of 2n, big O of n for the traversal, and big O of n, maximum big O of n, because we are heading and elements. If there are elements that are popping out, we are not moving till the end of our array. Maximally we are moving for n, but most of the time we are getting the elements in between, and we are able to find out NG without traversal up to n value. So it reaches big O of 2n, not n square. And that's how we are able to solve this problem. So this is a lead code problem, and there is another version of this lead code problem, and that is known as NGE2. There are some minor changes, and we have solved that problem also. So I hope you will try this question on lead code. I will also try it. And for next question, our next question states that we have to return the NG vector of our current elements. So that's our task, and there are minor changes, like suppose they have 2, 10, 12, 1, 11 as their array given, and we have to find ng for every element. So in this, before this, we were only able to move from left till right elements, or we have to find from left till right elements only. But in this question, if suppose that for 6, if there will be a 8 in our first value, we have to return that. So here's a circular array, so we have to find the ng for the circular array. If the array is present, if the value is present on the right hand side, it's best and it will be the first value. If it is not available, then we will check for left value or for the circular value as well. So it's the minor changes. And suppose and before this, we are trying with the decreasing order method, where we have taken the 6 element in our stack, and after that 4, then 2, then 1, and when encountering the 3, we have noticed that 1 and 2 are not fitting, and our graph goal is not decreasing, so we just pop them out. So by using this trick, we will able to solve this problem also with some minor changes. So let's simply think what will be the brute force for this. So for the brute force, I can think that we will be moving from 0 to n minus 1 for our I, and for j we will be moving from I plus 1 to n minus 1 if the element is present, or ng is present, we will only check for that. If in case ng is not present in that loop, so we will again check the loop from 0 to I minus 1 value, means left hand side value. So that's how we will able to find the first brute force is this. And we will be changing some minor changes, so we will be able to do it in a some good complexity. So for this, our brute force for the circular arrays will be, we will be running the loop from 0 to n minus 1, and again I plus 1 to I plus n minus 1, where we will be taking the modulo, like suppose we have an array, and now we are thinking hypothetically the copy of that array along with that array. So it's like if we have n side array, we are just making another hypothetical copy of 2n. We are not making it actually, we are just making it hypothetically, so that we should able to find the element and not traversing the whole array again and again, and that's how we will able to make our complexity to big O of 2n, not n square. So we will be traversing from I plus 1 to I plus n minus 1, means 2n. That's simple mathematics. And our index value will be j modulo n. Suppose our element are 5 elements. So 0 to 4 are the common indexing of our array. And now fifth element is on index. Sixth element is on index 5. So 5 modulo n, and where n is 5, that's 0. So that's pretty sure that our first element is our fifth element. So that's how we will able to run the loop. And if our array of index is greater from our array of 5, so our we will be updating it in our ng list, or if it is not present, so simply return -1, and that's how we will able to solve this problem. So it's also not the best solution, as complexity will be reaches to big O of n square for the first case, and time complexity is this, while the space complexity will be big O of n. That will be same for everyone, because we are taking extra vector to store the elements that is present in our question, or we can simply change in our current array if we wish. So it's not the best solution, it's just the better solution, not the brute force. So for the best solution, what I can think of is we will be making hypothetical array. So we have to make it sure that if we have an array and then we are just making that array's copy, uh, consequently attaching with our current array elements and making that hypothetical copy. Actually we are not making the copy, but we are taking the modulo operation in use case so that we are able to show that we are making a copy. So for this we will again apply the same as in our previous question. So we will be traversing from our last element and we will be checking. So let's take example of 5 elements. So 0 to 4 is their size, and our last element will be the ninth element, of course, of our array. So now we will be checking for the ninth element firstly, means 11. So example is 2, 10, 12, 1, 11. We will be find for them those element in that order. So traversing from the back, our 11 will be the first element of our copy element, copy array. So we does not require the NGE list for the copy array, so we will be just ignoring it. And as 11 may be a NGE of some one element, so we will be pushing it in our stack and moving backward. So again, next element encounters is our 1. So for 1, 11 is NG, but we do not require the copied array list, so we will be ignoring it. And 1 can also be NG for any element that will become on our left hand side. So we will be pushing 1 in our stack. Again now 12 element, 12 for 12, 11 is our NG. 1 cannot be the NG, so we will be popping out 1 and pushing the 12 in our stack. Now 10, for 10, 12 may be the ing, so we will be not changing anything and just push back 10 in our array. Now 2, that will be the sixth element of our array. That means our copied array first element. So for 2, 10 will be the ng, so we will simply put back 2 also. Now for the 11, and now we will be making the list or vector where we will be storing the NGE list. So for the 11, for this 11, we have to check in our current stack, as 2 cannot be the ng, 10 cannot be the ng, so they will be popping out, and 12 can be the ng. So 12 will be pushing in our list, and 11 will be pushed back in stack so that we can move further. And now again 1, so for 1, 11 will be the ng, so 11 will be pushed already, and 1 will be also pushed. For 12 we have not any ng, so simply returning -1 and popping out all the elements. After this 10, for the 10, firstly we will push back the 12, as 12 can be the ng of any element, and now the 10 and 10 have the ngs as 12, so 12 will be pushed back in our stack, a push back in our array, and 10 will be pushed back in stack as it can be the ng of any element. And lastly the 2 element 2, and for 2, 10 will be the ng, and then we have got all the elements while we have to push 2 also in our stack. So that's how we will able to solve this problem easily. Just make sure that you do not create another array. We have to think it hypothetically that we are encountering another array. So that's how we will able to solve this problem also. And with this, our both the problem of ng have solved using monotonic stack. And for the complexity, its complexity will be reaches to big O of 4n, big O of 2n for putting the elements from n minus 1 to 0 if the stack is empty or the stack's top element is less than or equal to array of I. So for that we will be simply pop out the elements, or if I is less than n, in that case only we will be taking I modulus n so that we can get the actual value, not the copied one. So for this ng of I will be stack dot if it is empty, so we will be taking the -1, or if it is not the empty stack, then we will simply take the top of the element of our stack as our new ng array list value. and at end we will be pushing all the elements of array of I modulo n, so that we are able to put all the elements in our current array. After this we will be returning the ng vector that has been created with this. So with this our complexity will be 4n, 2n for popping out the element and 2n for pushing the elements. So and our space complexity will be big O of 2n, big O of 2n, because we are taking a array and another copied of that array. So that's how we were able to solve this question and optimize the complexity with n squared to 2n. So I hope you like the video, you have understand the concept, and yeah, I have understand something that by telling the concept it's not easy to understand. I will be trying my best, and now from next month onwards, because on November I am busy, from next month onwards I will be trying to attaching some new videos where I will be able to make you understand the things on our notebooks or maybe on laptop. So for today that's enough, and good night, sweetie. Hope you like the video. So if you like the video, kindly subscribe and comment.